Welcome back to another episode of Impact Design. Today I'm going to talk to Pol Merino, who studied biotechnology and ended up with a company called Honext that he will tell you all about, that it's more than just about sustainability. So very nice to talk to you, Paul, and I'll let you introduce yourself. The first question, please tell a bit about yourself and your work.
Thanks, Yasmin. It's a pleasure to be here. I studied biotechnology, as you said, but I, right after university, I discovered that research was not really where I could give my best. And then I moved into business development. I was living in China for 3 years. And in 2015, a group of investors offered me the amazing possibility to lead Honext from a technological spin-off from University in Barcelona and make it a reality. And there I've been since that moment. It has been a really challenging project, especially because sustainability in 2015 was not a trending topic like it is right now. But right now, especially this year, 2021, and probably the COVID outbreak has had also an impact. But sustainability and circularity is the thing. It's happening, and people are starting to understand it. Let's say mass media are talking about it, so it's really the momentum for businesses really focused on circularity.
Excellent, thank you so much. So I researched you, and I was really intrigued by your company and the emphasis on potential of waste. So how do you assess? How do you came up with or your interest in waste, and how did you use? What is the product that came out of it, and how did you end up with Honext?
Okay, yeah. We first of all we are focused on cellulose-based waste. We don't treat with plastics nor any other. It all started because a paper mill came to us in the research group in university, and they showed us a waste they generated when using recovered paper as raw material. And it's mainly the fibers that are too damaged to be recycled anymore. They have to get rid of these fibers either by incineration or sending it to landfill, both costly processes. And thus they ask us, what can we do with those? And the easiest thing that what many people do with waste is putting some glue or some resin, binding them together and making a material with amazing mechanical properties. But that's about it, because once you put resin on something, it's impossible to recycle. And also many resins have impact on, they have volatile compounds such as formaldehyde and others. So we wanted to do things differently. And the first thing was, okay, we're not going to use any resin, because then we'll just give one more life to this waste, but it ends up in a landfill. And what we did was work with enzymes that actually increase the cellulose fibers' natural ability to bond among each other. They increase them exponentially. And so the mechanical properties of the material are generated through those enzymes. And afterwards, it was a process where we get this waste, we treat it with the enzyme, we have a cellulose pulp, and then we shape it as a board. That's the technology behind Honext. And over the past years, we've also been working on including several other cellulose-based wastes, such as agricultural waste. We're talking also about with the forest industry to input some of their waste. For us, we can use anything that has cellulose. The small difference is the pretreatment it has before entering the enzymatic process.
Very interesting. I think we're all curious to see maybe something. With my next question, it would be nice if you can share some images. You already talked about some amazing features of your material. Why do you think it's a good alternative to what's on the market, and where is its use to be seen mostly?
Perfect. I'll share with you some images on the material. It's a fiberboard, and why it is the advantages. One of them it's fully circular. It comes from waste. It is designed to have no emissions and to be 100% recyclable at the end of its life cycle. That no other fiberboard can say that. But apart from that, as a standard, the material has a better reaction to water than fiberboards for humid environments. Always talking about indoor uses, and it is a Class C reaction to fire. We are just about to launch the Class B reaction to fire, so that would be also getting the highest reaction to fire for bio-based materials. all of those products, or our product meets all cradle to cradle criteria. Actually, it's certified cradle to cradle silver, and anything that any innovation, any new product that we develop also has to be cradle to cradle compliant, which sometimes makes it more difficult because several additives are banned from the beginning, but it's just a matter of trial and error until we achieve it. The product is targeted to construction for indoor applications, for walls and ceilings. As you can see in this image, it can be installed as any wood-based board, and it can be transformed the same way, CNC, drilled like any wood-based board. Some projects that we have executed, but it's a decorative. Right now it is installed as a decorative panel. What you see is actually the material. There is no paint or anything applied on it. Just in this case, an oil to protect it. But it's an oil, again, meeting all the cradle to cradle criteria. It can also be used as an acoustic because it has a better sound absorption than MDF or drywall. And here are some finishes. Our idea and how we market it is that the material has to be seen. It's part of its value as well. However, it can be painted and it can be laminated as any wood-based board.
So it does take, it kind of is an alternative to many materials. Well, what do you see is the biggest advantage compared to what you could use in construction or in design, interior design in general? What would it, I mean, you said already MDF, because MDF does have normally also some toxins. Where would you see the main substitute for materials?
With our target is all wood-based panels used for indoor partitions. Not in furniture yet, because the fact that we do not use any resin has an impact on the mechanical properties. We are not yet as strong as MDF, but it's a matter of time. We are working on achieving the same mechanical resistance. We do meet all the requirements for indoor applications. Actually, in the next 2 months, we will have a European technical assessment released describing Honext process and product for indoor applications, and thus we can achieve the CE mark.
Mm-hmm. Interesting. And are you planning to, because you're already working with waste and coming from your biotech background, can you envision to have other sustainable construction materials or boards that could be developed from a lot of the waste products we kind of have today?
Yes, for sure. I mean, I'd say innovation is in our DNA as a startup. Like, we've become industrial because we had to. We have an industrial process, a factory running 24 hours a day. But it's 50. I'd say more than 50% of our efforts go on R&D and developing. We've already filed a second patent for a different process that makes more structural material. We are working on 3D shaping, and of course on inputting as many different sources of cellulose-based waste as possible. But for sure, for us, we just launched a product in the market this year. And what is critical is to actually develop based on the market feedback. That's why we've not yet launched many other things, because the market helped us prioritize our R&D.
What do you feel are the biggest today, the biggest challenges and issues in construction and design? Everybody is talking about, we have to come to a zero carbon footprint, and what can we do in architecture and design to contribute? What would you say for that?
To me, the biggest challenge is that as many systems are fully linear, and it's not possible to, with minor changes, to take something that is linear and make it circular. And say, I mean, the way construction materials are installed, the way when we go to furniture, and if we look, to design, and we look at furniture, many times we mix different materials that afterwards they can no longer be recycled, and that all ends up in a landfill. Like in Europe, the average citizen generates 1.8 tons of construction waste per year, every year.
That's crazy.
And that's because we actually extract virgin raw materials from mountains, build an amazing building with a lifespan depending on the building, but say 50 to 100 years. But then at the end of its life cycle, it ends up in a landfill. And to change that, we need to change all the process. We need to understand buildings as material banks, and to do that, that means that we need, when installing things, we need to install them in a way that afterwards we can recover it. And we also have to identify the lifespan of the materials inside a building, because if we identify them, we can set up an alarm in 10, 20 years time saying, hey, I have that there that I have to recover. And we can generate all the recycling processes to bring them back, because most of the materials are recyclable. The problem is when the way we install and mix them, that turns them in, that makes recycling so costly that it's simply easiest to throw it away and to extract the earth.
That is, I think that's a very important issue, like you just mentioned, about the circular economy, like you said, and taking the material that you just used in a certain amount of time and recycle it again. I think that would be that's a big advantage, that companies have to look much more into it. And I think you're showing it's a very promising alternative. How would you say, is it cost-wise to the existing materials? Is it like much more expensive, or would you say it's not really a big price difference?
Now we are more expensive than commodity materials, such mainly as like MDF or other partitioning materials, but we are much cheaper than other sustainable alternatives. Our goal is to be on the market on the price of a commodity, and it's a matter of scaling it up. It's simply right now we have a small production capacity of around 40,000 square meters a year, and that it makes no sense to position them at a commodity price, because it will not help us upscale production to achieve lower cost, and it also will not have visibility. And actually in this, we have also, when I told in the beginning we are fully circular, it's not just the product and the process that are designed in a way that they have no impact, but the technology the industrial technology that we have developed, it's designed in a way that it can be integrated inside paper mills. And therefore, we do not need to set up a huge factory to achieve a lower cost based on economy of scale, but we will achieve low cost by implementing small sites inside paper mills all over Europe. This way, we transform the waste locally into a product to be sold in the regional market. So we are avoiding filling up landfills, say in Germany, instead of that, giving them an alternative to a material that they are currently importing in the country. And it's simply, and that's our vision. And actually, we eliminate waste in this way. And it also, this network of distributed plants allows us to recover the material, because obviously, if I manufacture material here in Spain and I send it to Finland, probably the cost of bringing it back for recycling is crazy and it makes no sense. But if I have a plant in Finland, then it's just a matter of identifying that the material is there and it can be a Honext product again.
That makes a lot of sense to have to talk about locality and not having, because the whole transporting process itself is not really sustainable. So
it's 1/3, I think, of the impact of the global warming impact transport. The one thing is that it's cheap because it's been optimized, but it's cheap economically, but in terms of environment, it's simply so expensive. We cannot afford it.
So your idea would be to then work with different countries and have your manufacturing integrated into, which makes it really quite accessible, and that's great. Well, then I come to our last question that I ask everybody. What is the impact you would like to have on design, and especially in your field? What is it that you wish to see in the future?
To give the impact that we want to have is give designers the tools to design circular product and really generate a community with them, because as when we were discussing the market, to us it's critical to hear the market feedback in order to focus our development, because everything is achievable. It's a matter of really prioritizing, and we want to tell not just materials but how to transform these materials so you don't so they always keep their sustainable profile and their recyclability. So that's the impact that we want to have in design, giving the tools for designers to make 100% circular products.
Well, thank you very much for the interview. I think that is exactly what we need as designers and architects, to collaborate with companies like yourself to come up with products that have a truly circular economy and are going to protect our environment in the future. Thank you so much.
Thank you. Thank you for the interview.
I hope you enjoyed the interview with Pol Merino. I think that the circular economy is very important and not much regarded today. It's not just about the sustainable material or construction technology, but what happens afterwards. What is the waste product? What waste are we creating? I hope you got inspired and you got some new insight, and please do share with your colleagues and friends, and see you next week.